Hwaba, can you see? Hwaba? Okay, I don't know what happened. Right, let's start. We start with February, March. Then we go to May, June. And when we do May, June, we do 4-1, then 4-2, then 4-3. Then we go to October, November, like that. And let me say something. Right now we are doing a lot of paper fours. Wait. All right. Right now we are doing a lot of paper fours. We should then be able to go to paper twos. We need to also do multiple choice. Class, it's not a joke, that one. So we need to make sure we do a lot of multiple choice until we stop getting any mark below 36 out of 40. Because I want to make, if you guys get A stars for me, I'm going to be the happiest. I need them, guys. Trust me, Kuzi. I need you to get an A star for me, okay? So we're going to do a lot of hard work right now together. The hard things, I'll be doing them with you. And we do past papers. I should see you get 36 and above for multiple choice. And I should see you get, I don't know, whatever, big mark for paper fours. So let's get started. And we're doing waves, but we're doing the calculation. So here is how you do. We've been doing a lot of theory, seeing how to draw ray diagrams. I'm going to summarize the chapter. I'll do one last lesson for this chapter where I summarize everything. And then I just do a lot of questions with you guys like I'm doing for organic chem on every single thing. But before that, I want to do a section. So physics is so easy. If I can get everyone in this class to feel the way that I feel when I look at physics, that's the best. Lehakwa, when I scroll through a physics paper, I know I can solve everything. It's the hard work that I did. We should do it until you all feel the same way. We can do it, students. We can do it. Kuzi, you're smart enough, all of you. Just stick to the rules. So all these things are easy. And I know I can solve them, and I know you can solve them. You should be able to. So here's the thing. We get to a question. This one is asking us to just draw a ray diagram. So it's not important. And the importance of electromagnetic waves. Okay, here's a calculation. State the approximate speed of radio waves in air. Here, it's not really a calculation, it's a value which you must know. Let me give you, yes? Oh, you don't do physics, Tepi. Oh, okay. So I'll tell you when we're done with it, okay? I'll tell you when we're done with it. No problem at all. So when you're doing chapter 3, waves, it's so easy. The calculations that they ask you, I want you to just write these formulas. V is equal to F lambda. Write these formulas, please. Write these formulas down. You're just going to write them down. V is F lambda. And then you say frequency is equal to 1 over period, which also means period is 1 over frequency. Right? Then I want you to now write refractive index. So this is the speed of waves. This is going to be the frequency. And this is going to be the wavelength. If you see any question that asks you to find wavelength or speed, you have to use this formula. There is no other formula. It's like the stoichiometry I was doing with the Form 3s. I gave them the formulas that solve every single question. I'm going to do it again with you, or I'll share the video so that anyone who wants to watch can watch, in case stoichiometry is hard for you. We were doing past paper questions, so it will really help you. It's the same thing that we do for everything. There are formulas, and we know, we don't care how they ask us. They are going to try to trick us because they want some people to get A's, some B's, some C's, and whatever. Don't be part of those that get tricked. The formulas, we will choose one from this list. There is no other way to calculate anything besides what we are doing right now. So these are all the formulas for every single thing. Say, are you 100% sure? I'm 100% sure. The V is F lambda. Frequency here is 1 over period. So if you have, oh my days, sorry. Give me 1 second. So if you have frequency and they ask you for period, is a fixture. If you have period, which is time, and they ask you for frequency, easy again. Now the other thing, N, refractive index. Let's put the formulas. We will use one of them. Don't worry about theory. Just look at what you've been given. Choose one of these formulas. You're done. Refractive index, we have first formula. You should just know how to write these formulas. 1 over sine C. And this is if they give you something called critical angle. This is refractive index. So if you're looking for refractive index, either you use this or you use this one, which we call Snell's law, sine I over sine R. And I'll show you where they'll try to trick you here. They'll try to trick you by giving you the wrong angle. This I is the angle of incidence. Okay? Angle of incidence. This R is the angle of refraction. Are you seeing, students? Hello? You can't see the screen? I think I tried to make you see it. Try to quickly leave and re-enter. You should be able to see it. Try to quickly leave and re-enter. You should be able to see it. I will just want to do several questions, okay? Now, the last one, everybody, right? N is equal to, we can say C over V, which is the refractive index. That's the last formula. C over V. Speed of light in a vacuum divided by speed of light in the medium. If you have these formulas down, you have all the formulas for this chapter. There is nothing that you don't know now. And I want you to know that this C is the speed of light in a vacuum. 3.0 times 10 to the power of 8 meters per second. Okay? Can you see this? Okay. You can put this. This is the speed of light in a vacuum or in air. We can even say in air to be around the same value. Now let's go for it. So class, here they said. Here, let me tell you now something. I told you, and we all agreed, that all the electromagnetic waves are types of light. All the electromagnetic waves are types of light. So they will never say to you light. they'll say one of these waves. Either they'll say radio waves, you have a radio wave, or you have a microwave, or you have an infrared, or you have something in the visible light region, you know, or you have an ultraviolet, you know, or you have X-ray, or you have gamma ray, which you can write it as gamma ray, X-ray and gamma ray, or they can put that other sign. So if you get this, this is light. All these are types of lights, and they all move at the same speed. 3.0 times 10 to the power 8 meters per second. So don't let me down here, students. Don't let me down. Right? Please. So let's go. They say, state the speed of radio wave. It's light. State the speed of light in air. 3.0 times 10 to the power 8 meters per second. Are we together? Are we together, everybody? Okay, good. We'll go to the next one. Let's go to questions. Let's do several questions. Then I give you for you to answer. So anyway, February, March 2024. This was the only question which you needed to. Let's go to May, June, paper 4.1. And we are moving fast. We now know all the things, so we should be able to do the calculations. You go to chapter 3, and you're going to see them asking you to say, calculate the speed of light in glass. Right. Look at this. Don't think. I don't want to see you thinking. Any question which says calculate, I don't want to see you thinking. If you think, I'll be so disappointed. What you do when you see, oh, I have a question which says calculate for waves, just put the things that we know, the formulas we know. We know that I should know V is equal to F lambda, formula number 1. We know that I should know that frequency is 1 over period. Okay. I should know that, which means period is 1 over frequency. Okay. We should know that. We know that. We know that we should know that N is equal to 1 over sine C. That is if they give us the critical angle. N is equal to sine I over sine R. If they give us angle of refraction and angle of incidence, then we know that N is equal to C over V. The speed of light in air divided by the speed of light in the vacuum. So let me tell you, the only way you can find the speed of light in the vacuum, like speed of light in a glass or the speed of light in water, or you have to calculate it. But the speed of light in air, you already know, is 3.0 times 10 to the 8. Refractive index, either you are given it or they will ask you to calculate it. So this N and C over V. So let's look here. I have been given refractive index. So I have N. Okay, we don't choose. Don't choose before you go through the information. Let the information choose for you. Here you have the speed of light in air. So you have C. Once you have N and C, then they want the speed of light in the glass, which is V. So you already know which formula to use. Look here. Which formula should I use? This one. So you just come and write N is equal to C over V. Because you know all the formulas that work. And this is one of them. So N is equal to C over V, which is going to be equal to, what's your C? Look, now they want you to find speed of light in glass. Yes. Yes. Still ending at 10 when schools open. Yes. Yes. Okay. Now, you have N, you're looking for V. Make V the subject. Here's how you make V the subject. You swap it with N. So you end up having V is equal to C over N, which is going to be 3.0 times 10 to the power 8 meters per second over N 1.5. That's your V. What do you get as V? 3.0 exponent 8 divided by 1.5. What do you get? Yes, these are the yes, these are the formulas for chapter 3 for the whole of waves. Any question which says calculate, you get a lot, should use one of these. Okay? C stands for speed of light in air. So once you've been given speed of light in air, they don't have to give you, you should always know it. It's 3.0 times 10 to the 8. It will never change. Yes. Okay, good. What do you get? Say in the calculator, say 3.0, then say EXP, then say 8. It means times 10 to the 8. What do you get? Then say divided by 1.5. Tell me what you get as your answer. What is the answer, students? Two point zero times 10 to the power 7 meters per second, because it's speed. So it's meters per second. 2.0 times 10 to the power 7 meters per second. That's how, yeah. So don't change the steps. When you see a question which says calculate in waves, put these formulas for me, please. Okay? 6 of them. Then choose one which works and you'll get your answer. Don't even think. I don't want you to think any question which says calculate. So let's see if they have another. Calculate the actual distance between the point. Okay, so here and the time it takes, let's do this one, is again on waves. So they're saying the wave is represented as a wavelength of this. You've been given the wavelength, which is lambda. Then they're asking for the distance between point J and K. Distance between point J and point K. Here's the thing. This is actually not really anything to do with a formula. This is really not anything to do with a formula. It's everything to do with, listen, it's not anything to do with the formula. It's everything to do with, do you understand in these, do you understand what wavelength means when you have these type of waves? Right, look at this. This is called, remember, longitudinal versus transverse. So this is a longitudinal wave. Right. Longitudinal waves, wavelength will be from, this is called compression, where they are together. Compression until you get to compression again. When you do it like this is called a wavelength. So compression to compression is a wavelength. Now, compression to this point where they are spaced out, this is called a rarefaction, where they are spaced out. From compression to a rarefaction, this is lambda over 2. So this is half a wavelength. This is half a wavelength. So when you say wavelength plus half a wavelength, you get 3 over 2 wavelengths. You get 3 over 2 wavelengths. Are we together, students? You get 3 over 2 wavelengths. So here we have been given what one wavelength is. And we now have 3 over 2. So you can say distance. You just are showing that you know what it is from compression to compression and from compression to rarefaction. So it is 3 over 2 wavelengths, because we have wavelength to wavelength, which is 1, plus this half, which when you combine, you should know that you can say 1.5 wavelengths. It's still fine. I don't mind. For those who don't want to say 3 over 2, you can say 1.5 wavelengths. So you can say it is equal to 1.5 lambdas, which is 1.5 multiplying 1.2 times 10 to the power of 4 meters. So this is what it was checking. Do you know what a wavelength is on a longitudinal wave? Get me the answer. What is it? Get me the answer. What is it, student? It's 1.8, I think, times 10 to the power 4 meters. I think so. Then now you have this distance. They're saying now the wave travels through the ground at this speed. So you've been given speed, say v. The wave, okay, give me a second. I have a call. Hi. Okay, thanks. Then now you say the wave passes a certain point. As the wave passes a certain point, the ground completes 5 oscillations. So here you have the number of, remember, frequency is the number of oscillations per unit time. So for per second. So here it travels at this per second. It travels through the ground at this speed. Then here they are saying it passes through the ground. It completes 5 oscillations. So we can say the frequency is equal to 5 hertz, which means 5 oscillations per second. Are we together? Now calculate the time it takes for the wave to pass. Now here is another thing which we could have done, because we have the number of oscillations. Look, we have the speed v, we have the number of oscillations 5, and they are now saying calculate the time it takes for the wave to pass. They are looking for time. Let's go to these formulas of ours. Can you all see, students? If we say v is equal to f lambda, this is 1. Then if we say frequency is 1 over period, this is another one. And period is 1 over frequency. This is another one. Can you see that? Hello? Okay. So if you look here, this is the seismic wave passed by an earthquake. Okay? So here they said the wave represented has this wavelength. This is the wavelength, students. So if I have the wavelength, I can find the frequency. I know the wavelength of this wave. I was given in part 2. So here they said the wave in 2. Why did they say that? To mean it's the same wave with the same wavelength. So you know that v is equal to f lambda. You can get the frequency. So if I get the frequency, let's get it. I know the speed of this wave. I know its wavelength. This I'm not sure if it's the frequency. Let's just say we've been told that these are 5 oscillations. So let's say v is equal to f lambda. Let's find frequency. V over lambda is equal to f. What is the speed? 4,600. Don't rush. Meters per second divided by, what's the wavelength? We were given there 1.2 times 10 to the 4. Okay, I will need you to do a lot of past paper questions until your confidence rises. This is equal to know that there is nothing you get which doesn't have the formulas you've been given already. So find me the frequency here. What is that value? What is that value, the frequency? 4,600 divided by, you open bracket, you say 1.2 exp4. What is the answer? 4,600 divided by 1.2 exp4. What do you get? So your frequency is 0.383. Can you have it as a fraction? Change it to a fraction. 23 over 16. 23 over 60 hertz. Now you have this frequency, right? So what is the frequency, guys? It's the number of oscillations per second. So the frequency is the number of oscillations per second. Now they're saying, calculate the time. So, the frequency is the number of oscillations per second. Now you have been given this as the time. So let's get me the number of oscillations per second. What is it? It's 0.33 whatever. What we will now say is, how many times, these are the number of oscillations that happen in 1 second. How long does it now take to do 5 oscillations? So you say the time will be equal to 5 oscillations divided by the time it takes to do, by the number of oscillations in 1 second. So divided by 23 over 60 oscillations per second, which is hertz. That is how you get the time. So it now comes from you knowing that frequency is number of oscillations per second. So what is it that will be? What is 5? Then you say divided by, open bracket, 23 over 60. It's the same as saying 5 times 60 divided by 23. Then you find the time in seconds. What is it going to be? What is 5 times 60 then divided by 23? Five times 60 divided by 23. It's what? Okay, 13.04 seconds. So you now write 13.04 seconds. Bit of an ugly question, but still you got it. This was paper 4.1. Let's just go to paper 4.2. Let's keep it up whilst we edit. The more we do, the more we get used to them. Questions like this. We go to chapter 3. It starts here. Calculate refractive index of the glass. You've been given critical angle C. You know already, you don't even need to, that the only formula we have which has the critical angle C, it's N is 1 over sine C. N is 1 over sine C. So there we go. N is 1 over sine C. So it will be equal to N is 1 over sine 42 degrees. Which is, what is 1 divided by sine 42? What is 1 divided by sine 42? What is 1 divided by sine 42, class? You can write all the formulas. You still find there's only one with critical angle, which is this one. What is it? 1.49. 1.49. That's N. And you move on. So you see that we don't think, right? I hope I'm teaching you how we actually do this. Okay? Now we go to here. Let's see this one. Frequency, speed. Calculate wavelength. Come on now. You can write all the formulas, but there's only one which has speed and whatever. Its V is F lambda. So you can now say they want wavelength. So V over F is equal to lambda. What is the V? 1,500 meters per second over frequency 13 kilohertz. Be careful. This is lambda. So I always wondered, why did they give you 3 max? Why is it 3 max? Because here. Because kilo. Because of kilo. Kilo, they are. If you don't change it, you will be wrong. So let's change kilo. Kilo, you should know it is times 10 to the power of 3. So you will now say 1,500 meters per second divided by 13 times 10 to the power of 3 hertz. You should remove kilo. It should never be in kilo, or else you're wrong. You don't calculate anything with prefixes. This will give you your lambda. What is that answer? Tell me. Tell me. Yes, you say 1500 divided by open bracket 13 exp 3. It means 13 times 10 to the 3. This is equal to lambda. You said 0.1154. All right, so this is 0.115 or 0.12. We can still allow you to say that this is meters. Lambda is wavelength is a length, so it's like this, 0.12 meters. Questions? Questions? All right, 0.12. State the speed of sound in air. What is it? 3.0 times 10 to the 8 meters per second. This is fantastic. You keep doing this, you always get all the questions correct. So, what did you learn from here? You learned that when you are calculating in physics, put units at every step. And when you see kilo or gigahertz or nanohertz, stuff like that, be careful. Change it to what it means. I'll teach you all the prefixes. Let me teach you right now. Here are the prefixes. Can you write with me so that you know the prefixes? You should start practicing them. Okay? Let me teach you the prefixes. I taught you last time. Do you remember this, Antonisha? The kilos, I want you to know what the prefix is. So can you write for me? Prefix, then I want you to know what it means so that you can be able to remove it and put its conversion factor. Its conversion factor. How do you see a prefix? They'll put it in front of a unit. You know the unit should be hertz. So anytime it's something which is not hertz, be careful. It can get you. Don't let it get you. That's why you must put the units at every step of your working. I'm counting on you. I'm counting on you, my students. I'm counting on you. I'm teaching you right now. Look at the prefixes. You can remember them. How you should know them is it's powers of 10. So you'll be converting to standard form, which means times 10 to the something, times 10 to the something, times 10 to the something. That's a prefix. It is when it is something that helps us to convert to standard form. Times 10 to the power of 3, times 10 to the power of 6, times 10 to the power of 9. This is standard form. When you write a number with times 10 to the power of something, it's standard form. So prefixes help you to do that. Am I being heard? So these prefixes we must know. Right? These things we must know. So let's start with them. Say times 10 to the power of 3. We start with the positive ones. It's times 10 to the power 3, times 10 to the power 6, times 10 to the power 9. These are the ones you must know. Okay? At IG. I can put times 10 to the power 12, but I don't think you have to know it. But anyway, we just put it. So this is the kilo, which is a small k. So when you see a small k in front of your unit, like here, kilohertz, that's kilo. And you should remove it and put times 10 to the 3. Then you put times 10 to the power 6 is mega, which is a big M. It will be in front of your units. Then this one is giga, which is a big G. It will be in front of units. Then this is tera. It will be a big T. It will be in front of your unit. So big T is tera. Big G is giga. Right. Let's do the last things. I'm sure I gave you enough time to write it. Let's write these last ones, the negative one. So people who know computers, you start with kilo when it's like a picture. A picture is the one which is in kilobytes and whatever. Okay? Then you need mega, then you need giga, then you need tera. Okay? Right. You understand? Here, now, tera, it's kilo for pictures, megabytes for things like songs. You keep going. Then gigabytes is the bigger one for big things, like this whole lesson. All these hours, when you look at the size, it's gigabytes. Then terabytes. Ooh, that's big storage now. Like when you see all the videos I've recorded together, they make some terabytes. Now we go to the negative ones. So the negative ones, I want you to know that it's instead of just -3, of course we do -3, -6, -9, and times 10 to the -12, and we are done. So all of you, this is where A-level physics will start. For all those who we want to do A-level physics, it starts here, and you'll be using prefixes much more. It starts here. But you should know that -3 is now what? Milli, which will be a small m. You see it with a small m. Then this one is micro. It comes a lot. It's a U like this with the belly in front. That's micro times 10 to the -6. Then you should know nano. That's n. Then you should say pico is small p. Then you should know centi is small c, which is times 10 to the -2. This is the only weird one because the power is not a 3 timetable. It's not a multiple of 3. But otherwise, everything else, fine. So, prefixes, if they're in your working and you don't remove them, just know that I've told you right now. The answer you get is false. So you are part of the students that will be trapped and part of the students that will lose marks thinking they got them and get a C. You are not one of them. Be careful. Don't rush. Here are the steps. You have the formulas down. V is F lambda. F is 1 over T. T is 1 over F. N is 1 over sine C. I only use it if I have the critical angle and I want refractive index. N is equal to sine I over sine R. We need to do more questions, eh? N is equal to C over V. So I'll choose one from this list as long as it's a chapter 3 thing to do with waves and stuff. I don't want to know anything. They should not waste my time telling me, hey, do this. I don't want to know it. This is enough information for me. If I use it correctly, I can solve any question that says calculate or says determine. This one says calculate wavelength. So I put the stuff I have. They want wavelength. They've given me speed V. And they've given me frequency F. Which formula has these 3 symbols? This one. So you put it down. V is F lambda. Then you see what they want. Wavelength, lambda. You make it the subject. You take frequency to the other side. You have like this. Then you can now replace. You replace. You put the things. Then you are going to see kilo as you are replacing, because when you are replacing, you are putting with the units. Then you see the word kilo. You'll be like, oh, they think this was going to trick me. I'm too smart for this, man. I know what kilo means is times 10 to the 3. So you remove it, you put times 10 to the 3, and it's now hertz. Perfect. Then now you punch and you get your solution and you'll be good to go. Is there anyone with a question? All right. So I'm going to go through several past papers tonight and choose the ones that have questions related to the ones we've just done. Or any question, actually. I want you guys to learn to express yourselves. Yeah? Any question, actually. And I want to see how you use this information. How good you are at using this information. So I'll choose whatever question I want. Let me just tell you one thing which can be a problem. Let's just say they give you something which is bending, right? They give you a wave which comes and bends like this. And they give you this angle, 32 degrees, and they give you this one, whatever, 20 degrees or whatever. Let me tell you right now, and they ask you to find the speed. There's a trap here. They always do that. Here is your ray or whatever the wave. This is the boundary. So, when you get angles, which formula is it that has these angles? It's this one, sine I over sine R. But I and R are not these ones. I and R are the angles with the normal. So they're actually not these ones. So that means the angle of incidence is actually supposed to be 90 minus 32. Then you get it. Then here you say 90 minus 20, you get 70. These are actually the angles. This is your I, this is your R. It's the angles with the normal. Then now you will put them in this formula. So be careful on that one. Other than that, you'll be fine. Yes. Stoichiometry. Yes. Yes, I'll give you. Okay, I'll post the lesson we did, and then I'll send the link in the class for whoever wants to do chapter 3 for chemistry, 3 out of 12. It's stoichiometry. It comes in every single paper, almost every single paper. So there's a 99.9% chance it's coming in your exam. So you must know it and start to do some practice questions. I'll send you that video, and you guys will go through it. For the things we've done tonight, is everybody fine? Are you all on the same page? All right. So you'll get there, Roderick, huh? Okay, LGK, wait. Yes, okay. Roderick, fine. What did you say? Yes. Yes, by practicing, yes. Write these 6 formulas. Don't do it any other way. Write these 6, then choose one. You guys will manage. All right, LGK, let me now do the question you have asked. So this is the end of the physics one.